Hello, welcome to session MGT 306. My name is Kumar Jagannathan. I'm a global specialist solution architect and I focus on observability here at AWS. In this session, we will talk about how you can make use of various AWS observability tools to increase availability in your environment. Well, what is observability? The term observability itself originates from the field of control theory, where it basically means that you can infer the internal state of the components in a system by learning about the external outputs or signals it is producing. You might wonder how it differs from monitoring and what value this adds. The difference between monitoring and observability is that monitoring tells you whether a system is working or not, whereas observability tells you why the system isn't working. Also, if you set up good observability in your environment by using the right tools and processes, observability can also enable you to answer questions that you didn't know you needed to ask. From an AWS perspective, we believe giving the ability for developers and operators to get deeper insights into issues such as errors, faults, latency problems, that is, internal states, by correlating external signals such as logs, metrics, and traces across different services together through powerful visualization, analytic abilities, and easy-to-use insights empowers observability of a system. We also try to push the boundary a bit further by trying to identify potential application issues through machine learning algorithms based on the collected data. Let's first try and understand some terms and concepts. Now let's take a look at an issue timeline. Here's the overall issue start and end timeline. When an issue starts, that is through an email notification or a pager going off, some time gets lost already to detect the issue itself. The lost time could be really short or longer based on how your alerts work and the detection mechanisms you have set up. MTTD is mean time to detect, which is a measure of the mean time it takes to detect issues in your environment. Then comes the identification phase. Plenty of time tends to be spent here because this is where you are trying to ascertain the root cause of the issue. Once again, this could be really short in certain cases. In cases where you're dealing with a repeated known issue, you might quickly be able to jump into fixing the issue based on past experience. But in most cases, this tends to be more complicated and gets even more complex in a distributed system environment. MTTI is mean time to identify and is a measure of the mean time it takes to identify issues in your environment. Then you enter the fix and verify phase, where you now know the issue details and you understand what the exact fix that need to be made, and then you verify whether the fix is actually working or not. Our area of focus primarily is to reduce MTTD and in fact MTTI in general. This is where we have a lot of control over what we can do in setting up systems and processes to quickly identify and pinpoint issues. Setting up better observability is a matter of progression and maturity in that area. Your maturity in this space grows as your capability grows. As I mentioned earlier, observability expands the monitoring horizon. We are now building systems that can detect patterns in signals from a variety of services and identify anomalies that could lead us to the cause of the issue. Observability is exactly that. Being able to identify issues quickly and act on those, if possible, sometimes even before your end users are experiencing them. Let's take a look at some of the key tools that you can use to monitor your environment today. AWS X-Ray allows you to collect traces from a distributed environment through an X-Ray agent or API calls, etc. And you can make use of powerful tools such as X-Ray Analytics that allows you to analyze, filter, compare trace sets, etc. to identify problems from trace data. This makes it possible to identify issue, root cause, faults, latency sources, etc. very easily. At the same time, using the CloudWatch agent, API calls, and other mechanisms, you can collect logs from a variety of environments on AWS and on-prem resources. Then you can use the purpose-built, powerful query language on Logs Insights to analyze the log data from a log group or across numerous log groups. CloudWatch agent also helps collect metrics from a variety of computer environments as well. Using metric math expressions, dashboarding on the metrics, and other metric-related functions, you can understand and analyze the metric data. This could, for example, allow you to understand a service performance. What if I'm able to connect and correlate all this information so that I can understand the service performance, service latency, and the application or business context all together at the same time? If it is possible to correlate all this data yourself, but it's just time consuming, repetitive, and sometimes it can also be error prone. Having that in mind, let's take a look at how a typical troubleshooting workflow looks like. As you can see, there are different detection and identification actions that take place. While it can perfectly get everything done, and you will be able to make use of the features we discussed in the previous slide to troubleshoot problems in your environment, it still presents data silo challenges. Mainly take a look at the analysis section happening at different times based on what you discover in the troubleshooting journey, and also you constantly trying to correlate the data to put all the information together. The question is, how do we solve that problem? Yes, some of these problems can be solved by process tweaks and custom tools, etc. But you really need a robust platform to solve this problem in a consistent manner. This slide shows how AWS Observability itself is positioned. We are building our observability tools on a strong building blocks we already have in terms of logs, metrics, and traces on CloudWatch and X-Ray. We are adding observability capabilities on the platform to solve specific use cases and at the same time give you the ability to get a holistic view of your distributed environment. The AWS observability tools are not only feature-rich but also extremely easy to set up and maintain. Let's take a look at them. Well, a variety of tools exist on the AWS observability platform for you to make use of. You can broadly classify them under infrastructure monitoring, application monitoring, and synthetic monitoring. Other than the tools you have at your disposal, the real impact of strong observability is how you use the tools, set up your process to suit your business needs and the business demand and growth. Our goal is to solve the problems we laid out earlier. During the rest of the session, we will take a deeper look into all these services and also be able to see some of them in action. Let's begin with Container Insights. We built Container Insights so customers can easily ingest logs and metrics from their container environments without having to go through challenging setup processes. We launched Container Insights last year, and since then we have enhanced the metric and log collection ability by adding Prometheus metric support with the CloudWatch Prometheus agent. Now let's go and take a look at the Container Insights console to see it in action.
This is the Container Insights console. Once you enable Container Insights on a cluster, you will be able to see the cluster resources populated here. You can also see a map view showing the cluster resource hierarchy. You can select any node here and see some key metrics, such as CPU, memory utilization, network traffic, and CloudWatch alarms for that particular resource. There are two modes called CPU mode and memory mode. The nodes are color-coded based on the mode selected and the utilization metric related to that. Clicking on View Dashboard will take you to the performance monitoring screen with the resource selected on the map view. The dashboard widgets on this screen show metric information that is relevant to the selected resource. At the bottom in the task performance table, you can see the tasks that are part of the ECS service selected. Here you can select the task and the application logs and performance logs using the action menu. Clicking on the performance logs, it takes us to the Logs Insight screen with the log group selected and with a sample query that will fetch performance logs from the task. You can also select other cluster resources using this drop-down. Let's select ECS tasks, and now you can see the metric widgets changing to suit the type of resource selected. You can also see that the cluster container performance table showing all the containers that are part of the tasks from this cluster. For popular workloads such as AppMesh, Java JMX, HAProxy, etc., we created out-of-the-box dashboards for customers to easily monitor those environments. Metrics from the container environments are collected under the ECS Container Insights namespace in case of ECS and under Container Insights namespace in case of EKS. You can make use of the metrics features available in CloudWatch, such as anomaly detection, metric math expressions, and dashboarding features to leverage the metric data collected.
CloudWatch Lambda Insights. Lambda Insights provides built-in dashboards that are custom built using metrics collected from the Lambda environments, giving you all the critical information you need. Let's take a look at the Lambda Insights console to get to learn about the features.
We are on the multifunction screen on the Lambda Insights console. You will be able to see a variety of metrics from all the Lambda functions in the account in the current region that have Lambda Insights enabled. If you're interested in seeing only a subset of the Lambda functions, you can do so by simply selecting from this drop-down here. There are a variety of metrics available for you to make use of. You can also directly go to CloudWatch Metrics by simply clicking on the widget and clicking View in CloudWatch Metrics in the expanded metric widget screen. Under the function summary table, you can see details about the number of invocations, CPU time, network I/O, max memory, and the number of cold starts for each Lambda function. You can also see the performance and application logs for the Lambda function by clicking on the Actions drop-down. Here, you can see that we are in Logs Insights, where the log group has been selected, and with a sample query that will help us fetch performance log data from the Lambda environment. We can also dive deep into a specific Lambda function by clicking on the function name under Function Summary. Here, we are able to see Lambda-specific metrics such as invocation and errors, duration, throttles, etc. At the bottom, we can see details up to the last 1,000 invocations and application logs. If the invocation was traced, we will also be able to see the trace map by clicking on this link. This will take us to the ServiceLens console, showing a map of the trace and its segment timeline. Not only this gives deeper insights into the request sequence in which this Lambda invocation was involved, but it also gives insights into details of actions involved in the request pipeline. In addition to this, we can also see the logs generated by the different services in the service map while this particular invocation took place, giving deeper insights into the application and business context. This generally is very helpful for developers to identify issues.
CloudWatch Contributor Insights. Contributor Insights allows you to create time series data out of CloudWatch logs of top contributors. You simply create a rule that will be applied on the target log group or more than one log groups, and Contributor Insights will create a live top-end report for you based on that rule. At the moment, you can analyze both JSON and CLF log formats. Using built-in rules, you can analyze logs from other AWS services such as Amazon DynamoDB. Let's take a look at the console to see that in action.
This is the CloudWatch Contributor Insights console. Here you can see that I have Contributor Insights enabled for one of my DynamoDB tables, and the automatically generated rules are shown here. Here this rule shows the top DynamoDB partitions that are being actively accessed. Here's another rule that creates top-end report based on partition key, sort key combination. This helps customers identify hot partitions in DynamoDB and make changes according to access patterns. You can also create your own rule by clicking on the Create Rule button, and either by entering a custom rule and choosing the log groups here, or you can also create a new rule by making use of the sample rules already available. I have created some rules based on the VPC flow log samples, which we will take a look. This rule shows a top-end report based on the number of actions from source IP addresses. Here's one more rule that shows source destination bytes. You can change the top-end count using this drop-down here like this. You can also change the metric aggregation duration and the order type. You can add the report as a widget to a dashboard, or also share the report data through other means using the export option here.
AWS X-Ray Insights. As you know, AWS X-Ray allows you to easily collect traces from your services, giving the ability to see a service map, analyze traces using X-ray analytics, filter traces using filter expressions, create X-ray groups based on specific filter expressions, and so on. Now with the newly launched X-Ray Insights feature, you can have actionable insights based on anomaly detection in AWS X-Ray traces. X-Ray Insights will also automatically identify anomalous services and identify potential issue for a service fault. Let's see X-Ray Insights in action.
We are in the X-Ray console. You can enable insights easily on all traces by turning it on the default group, or by creating a new group to only trace requests that match a specific filter expression. Here you can also enable the notifications to get the insight events delivered to Amazon EventBridge to take actions on the insight events. Once enabled, X-Ray will automatically identify anomalies in traces and create insights for any faults. The list of insights can be seen on the Insights screen here. This screen gives a summary of all the insights identified so far with a description that explains what each insight is about. When we click on an insight, on the Overview tab, you can see, among other details, about the current status of the insight, root cause service, what service caused the anomaly, and the overall impact during the period while the insight was identified. Under the Anomalous Services section, we can see the timeline that shows the insight duration. Hovering the mouse on the actual time when the insight was identified, you can also see more details on what the actual number of faults was and what was predicted. In this case, the AD model did not expect any faults. However, there happened to be one fault at this time which resulted in identification of the insight. Under the root cause section, there is a service map that also clearly identifies the anomalous service. And also under the impact section, you can see the total impact due to this event. You can also analyze the incident by looking at all the traces by clicking on the Analyze Insight button, which will take you to X-Ray Analytics and apply a filter expression for you automatically. In the Inspect tab, you can see the impact timeline, and in the Impact Analysis section, you will be able to see the actual impact on each event in the timeline for a deeper understanding of the incident.
CloudWatch Synthetics. CloudWatch Synthetics allows you to perform canary monitoring. You can create canaries that are basically configurable scripts that run on a schedule to perform heartbeat monitoring on applications, test API endpoints, and even perform UI automation to test user interaction. These canary script executions traverse through the same path in your applications as your real user requests would go through. Let's take a look at the console to see CloudWatch Synthetics in action.
This is the CloudWatch Synthetics console. Here you can see a list of canaries I have on my account in the current region, and also the execution history of all the canaries. I can click on a particular canary to see the details of it. This canary tests an API endpoint and validates its response. Here we can see the success percent on the list of executions that had issues. I created this canary to fail at a certain condition for demonstration purposes. The red dots here indicate error runs, and we can select any of them by simply clicking on any of those dots. Because this is only an API test and no UI was tested, there are no screenshots or HAR files. Let's go to the Logs tab to see the execution log details. I have enabled active tracing on this canary, and so we can see the traces generated by the canary run. We can see a quick overview of the segment timeline right in the console, and if we need, we can see the trace map by clicking on the Go to Trace Map button, which will take us to the ServiceLens screen and show the trace map. Under the Monitoring tab, we are able to see some key metrics that allow us to understand the overall performance of the canaries for a selected time range. Under the Configuration tab, we will be able to see the current configuration setting for the canary script. Finally, we can also see the canary in the service map on ServiceLens by clicking on the View in Service Map button, which will take us to the ServiceLens console and select the canary node. From here, you will be able to dive deep into canary execution by making use of ServiceLens features such as logs, metrics, and trace correlation.
CloudWatch Metrics Explorer. Metrics Explorer is a tag-based dashboard builder to filter, aggregate, and visualize operational health and performance metrics by tags or resource properties. It offers a flexible troubleshooting experience that allows you to quickly slice and dice operational data to pinpoint issues, identify correlations, and build application health dashboards. Tag-based dashboards will stay up to date with resources as the resources matching a tag changes. Let's take a look at the console to see that in action.
This is the Metric Explorer console. Here you can explore all the available metrics on CloudWatch Metrics based on a combination of resource type and resource tag. You can either start with an empty Explorer or select a template from the list. Let's start with an empty Explorer for now. I'm going to select all Lambda function metrics from the metrics lookup. I can further narrow down by selecting a specific resource tag or a property. Here I'm going to select Lambda functions that are written using Node.js. As you can see, the metric widgets get automatically populated with the selection options we made. We can also aggregate the metric data values using the Aggregate By option. We can also split the graph based on a specific tag value. Here I'm going to split the widgets based on memory size. Now I'm going to go ahead and add the widgets to a new CloudWatch dashboard using the Add to Dashboard button. With that, when a new Lambda resource gets created that matches the filter options chosen earlier, it will automatically appear in the dashboard without users having to do any work.
CloudWatch ServiceLens. ServiceLens is a feature that allows you to easily correlate logs, metrics, and traces together to help you get a deeper perspective of issues you're investigating. It helps you get a visual understanding of performance and service health metrics by automatically resizing the nodes, adjusting sizes of the edges, and also by highlighting problematic services for easy identification of problems. As you can see, ServiceLens also allows you to dive deep into other specific insight features to perform deeper analysis and get insights about a particular resource. Now let's take a look at ServiceLens console and see a quick demo.
Here we are in the ServiceLens console. ServiceLens has a service map view that shows all the services that are part of your application. In order to see this, the pre-requirement is that you have X-Ray enabled in your application. You can also change to list view to see all the resources in a list format. Now back in map view, you can see that some of the nodes are bigger and some of the edges are thicker. That's to highlight the services and routes that serve higher number of requests compared to the other services in the application. You can also change the view to latency mode where now the nodes and edges automatically adjust based on latency. Here, thicker edges indicate high latency route and bigger nodes indicate high latency from that service. This is extremely useful because when you have customers complaining about application sluggishness, you can simply see the service map to get a visual understanding of where the latency is occurring. Services having errors or faults can easily be identified with clear color coding. Also, if you have services that have alarms going off, you can see that as well, as you can see here. When you select a node, we also show latency, requests, and faults data to better understand the service performance. For nodes like Canary or a container service, we are also able to enable appropriate buttons so you can jump to that service for deeper analysis if needed. One of the main goals of ServiceLens is to make it easy for you to visualize and correlate logs, metrics, and traces for easier troubleshooting. Let's click on the View Dashboard button, which will show more metric widgets than we saw earlier, giving more insights into service performance. In addition to this, you will also see a node map which shows the upstream and downstream services that are connected to the service in question. You can also choose a different service from the drop-down here. Let's choose another service, for example, a Lambda function. You can see that the metric widgets automatically update for the selected resource, and also you can see the service-specific metrics right here, so you don't have to go to different screens to see such information. In addition to this, you will also be able to see the logs generated by the Lambda function. If you want to filter the log results and perform analysis, you can click on View in CloudWatch Logs Insights button, which will take us to the Logs Insights screen. Select the log group already for us to work with. Now let's click on the View Traces screen to see the traces originated from the service in question. You can see the total number of traces from this service at the top, and you can also filter the traces based on several filter options here under Filters. You can jump to X-Ray Analytics using the X-Ray Analytics button. That will take us to the Analytics screen with a filter expression already applied, showing traces that satisfy this condition. You can apply filters and focus on a subset of traces by simply applying the filters available here. When you add custom annotation to the X-ray traces, you can also filter based on those options like this. You can see the response time distribution of the traces in this area, and if you desire, you can also filter traces based on response time as well. At the bottom, you can see the traces based on the filter options applied above. You can select any of the traces to get into the details of the trace. Now this shows the trace map, which essentially shows how the request travels through the application. You can see the trace summary and the segments timeline below here that shows all the actions that took place in the application while this trace was captured. When we scroll all the way to the bottom, we can see that ServiceLens also fetches and shows logs that were sent while this particular trace was captured from all the different services that are part of the service map. This really helps understand the business and application context quickly and helps developers identify issues and reproduce the problem in their environment so they can fix the issue.
Okay, with all the new features we saw, your new troubleshooting workflow changes drastically. Here's how it looks. Take a look at the detection phase to begin with. Instead of waiting for your users to report errors or having custom error detection mechanisms, you could be notified by an alert from Synthetics, or might be notified by an insight from X-Ray through anomalies identified from the traces collected, which could potentially shorten the MTTD, or mean time to detect. Now look at the identification phase. Here you're now able to make use of ServiceLens to correlate logs, metrics, and trace data, and also, if needed, it guides you to the right tool to perform deeper analysis without switching context or scope, which is really critical to shorten the path to root cause identification. This can cut down the overall effort needed to identify the issue. The point here is that this helps cut down our overall MTTI, or mean time to identify. Here we can see the difference between the original approach and the new approach that makes use of some of the AWS observability tools in the mix. Take a look at the reduction in MTTI, which was our original goal to reduce. That alone contributes to better application availability, improved customer experience, business growth, etc., which are essential to any business. This process might vary a bit depending on the variety of factors, such as the type of environment, and so on. So this should be used as an approximation of an ideal scenario. As a summary, AWS Observability Tools has built-in features for specific resource types like containers, Lambda, etc., to get deeper insights into those environments. Helps easily collect and correlate logs, metrics, and traces to get deeper insights into those issues as well. Also, we use machine learning to identify anomalies so we can identify issues quickly. Above everything, all these insights features are built right into the services in most of the cases. To get a hands-on experience on all our observability features, visit our hands-on workshop site at the mentioned URL on the screen here. The workshop is also available in English, Spanish, Japanese, and Korean languages. You can interact with CloudWatch through a variety of options, including the Management Console, CLI, API, and SDKs. A list of ISV solutions that make use of CloudWatch and APIs are listed on the screen. Thank you for joining this session. Have a great re:Invent and take care.